Okay, we're going to be identifying some points on these graphs. First of all, we're going to talk about relative mins and max. Well, relative and absolute. If you're talking about an absolute minimum or maximum, you're talking about the very minimum or maximum of that graph. So, for example, the graph of a parabola. That has an upside down parabola. That has an absolute maximum. That is the very highest point that graph is ever going to go. It does not have an absolute minimum because it's going to keep on going forever and ever in the down direction. A relative min and max would be a graph like this. Okay, I have a maximum because I have the top of a hill, but it's not the absolute maximum because I'm going to have other maxes up here. So this one would be, this one's a relative, but this one is an absolute. Some people distinguish between the two as this is the maximum and this is a maximum. So whatever your preference. First thing we're going to do is graph this on the calculator, get a picture of it, and then I'm going to show you the operations to find the minimum or maximum. Okay, I'm going to put the equation in here. It is 3x squared minus 4x minus 2. I'm going to hit graph. Alright, so we have a parabola. So really what we have is a minimum right here. And we've got to figure out what that point is. To find exactly, you can hit trace. And you can take your cursor left and right along here, and you can get pretty close. But we're going to find it exactly. So we're going to go to second, trace. We know we want to find a minimum, so we're going to go to 3. And it's going to ask you to left and right bound. My left bound, I have to be anywhere to the left of that minimum. So I'm going to go over here and make sure I'm really to the left of it. Press enter. It's going to ask for the right bound. So I'm going to go over here and make sure I'm to the right of that minimum and press enter. It's going to ask you to guess. You don't have to guess. You can just press enter again. And it's going to give you the exact minimum. So our minimum, it would be 0.6 repeating, comma, negative 3.3 repeating. And we would call this, since it is the very bottom of the graph, we would call it an absolute. Okay, I'm going to go into my y equals, clear out what I have there. I'm going to put in negative x cubed, arrow over, plus x, and hit graph. Alright, this graph is going to have a minimum and a maximum. And just so we can see a little bit closer, I'm going to zoom in once. Zoom, zoom in, enter. It's going to ask you where do you want to zoom in on. I want to zoom in right there. And if I needed to go further, my cursor comes back again, I could press enter, but I don't. So I'm going to find this minimum. So I'm going to go second, trace, minimum. Again, I've got to left and right bound it. So I'm going to arrow over until I am for sure to the left of that minimum. What you're doing here is you are narrowing down the space that the calculator is looking at. So I want it to look between here and here and find the minimum point here. I don't have to guess, so I'm going to just press enter. And then I would write down that my minimum is negative 0.57735 and negative 0.385. Okay, to find my maximum, Go to second trace again. And this time I'm going to select maximum. I'm going to left and right bound that maximum. Well, I'm definitely to the left of that maximum where I'm already at. I'm going to arrow over until I am definitely to the right of that maximum. Press enter. Between here and here, yes it is. And I would write down my other maximum, 0.577.385. And since these are relative, because the graph does continue, I'm going to name this a relative minimum and a relative max. Intervals of increasing, decreasing are constant. Intervals of increasing are obviously going to be going uphill. Intervals of decreasing are going to be going downhill. This is reading left to right. Constant means it's not going up or down. It's staying constant. So on this graph, we have 3 different intervals. We're going downhill, 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 and it stops. And we're going uphill, uphill, up, and it stops. Then we start going back down. So if I name my intervals, well, up here starting at negative infinity, so parentheses, since you can't get to infinity, it's a parenthesis. Negative infinity, comma, you want the x values. So our x value was negative 0.577. And let's see, that was decreasing. I also have decreasing on the tail end here. And that is going from 0.577 to infinity. Since 0.577 is our turning point, we're going to leave them as parentheses on the ends. So this is my decreasing intervals. My increasing is in between the two. So from negative 0.577 to positive 0.577. So I'm going to put this function in my y equals. Clear that out. I'm going to be putting in x squared minus 9. And look at the graph. Okay, maybe I'm too zoomed in. I'm going to go back to zoom 6. Look at the bigger picture of this. Okay, so right here we can see we are decreasing all the way down until we get to some point here, and then we increase for the rest. We need to figure out what that point is. Since that is a minimum, I'm going to go to second trace, minimum, I'm going to left and right bound it, to the left enter, to the right enter, and then enter one more time. So this number right here, e to the negative 6, that is a very, very, very small decimal. It's like negative 0.00000024. Essentially that's 0. So my minimum is at 0, negative 9. So my interval, I am decreasing from negative infinity up to 0, and then I am increasing from 0 to positive infinity. Two different types of symmetry we're going to study are even and odd symmetry. You are even if you are symmetric with the y-axis. You are odd if you're symmetric to the origin. Always remember origin, odd, both start with O's. If you're symmetric to the x-axis, you are on both sides, so you would not pass the vertical line test, which meaning that you don't have a function. So graph these graphs on your calculator or on a computer, and try to decide on your own whether you think they are even, odd, or neither. Pause it, and then check yourself on the next one. Here are the graphs of A, B, and C. A is symmetric to the origin. I can take quadrant 1, reflect it over and under, and I can take quadrant 2, reflect it over and under. So since its origin, it is odd, so we have an odd function. On B, we have y-axis symmetry, same on both sides of the y-axis. This is going to make an even function. And then on C, we have neither. If it was scooted up a little bit, we'd have origin symmetry, but since we don't, neither.